Hello there, this is Mr. Dunaway, and it is time for us to get started in Chapter 1, Section 4. So in front of you, you should have these notes that say 1-4 properties of numbers at the top. Simply put, we have a lot of vocabulary we just have to kind of work through, and you need to become familiar with. So fill in the blanks as I fill them in, and hopefully we can get through this as quickly as possible. Number one says the word that you want to put in there is counterexample. And I need to get my pen ready. I'm not quite prepared. There we go. Counterexample. That's an example that shows a conjecture is not true. So if I said something and you could disprove it, you would give me a counter example that showed me that something I said was not true. We'll see an example of that in a little bit. And number two, the word for the blank there is simplify. To simplify means to write an expression in a more, it's two words really here, more simple form. And we'll get into that in some examples on the next page in a few minutes. The third one, deductive reasoning. Deductive reasoning is the process of using facts, properties, or rules to justify reasoning and to reach valid conclusions. Right there. So that's kind of a lot of what we do in mathematics when we prove things. That's deductive reasoning. And really what I want you to just experience the next couple of days are these number properties. So we are going to be filling in some blanks here based on these properties that are written right there. So what I think I'm going to do to maybe help out a little bit, I'm going to turn my shade on here so we can kind of focus at one thing at a time. Here is the first one. We're going to fill this property in right here. What we're talking about here, let's look at what it means here. Let's look at the words first. If 0 is added to any number, okay, just think about that for a moment. Consider what happens when 0 is added to a number. And hopefully you're thinking, well, the number doesn't change. And that's right. And we have a word for that. If you add a number, like I said, you know that it's, if you add 0 to a number, you know that's that number. We call that, write this down, the additive, lost my pen for a second. The additive identity. Hopefully you can write in the box because my ink is a little fat. It's hard for me to fit them all in there, but I think you can. Examples of the additive identity are right here. All right, you know 5 plus 0 is 5. 0 plus 5 is 5. Okay, that's called the additive identity. So on your work, you're going to be just going over these words and seeing if you can recognize them, those properties in actual problems. Let's look at the next one here. That is, I'm going to change color for a second to just help you keep straight what I'm doing here. This one says when a number is multiplied by 1, okay, the product is the number, right? Let's look at the example. It might make the most sense to you. 8 times 1 is 8. Most of you probably know that. So notice on that one, when you multiply it by 1, you get the number you started with. That is called the they have this different way of saying it, but just write it down, multiplicative. You can kind of see the word multiplication in there. That's the multiplicative identity. Okay, so notice in these two properties the word identity. Those are the properties where you end up with the result of what you started with. Like 5 plus 0 gave me 5. It's the adding identity, additive identity. 8 times 1 gave me 8. That's the multiplicative identity. So what I would like to see is mainly that you can remember this word identity when you get, the same number that you started with when you add or multiply something. So the additive identity would be to add 0. Multiplicative identity would be to multiply 1. All right, hopefully that makes sense for you. And then the third number property, another one you should know. If you multiply any number by 0, the answer is 0. Right, we know that. Well, we call that the multiplicative property, I'm going to abbreviate, of 0. The multiplicative property of 0, examples here, means if you multiply some number times 0, you get 0. Right? So if you see that, that's what you call it, the multiplicative identity. Okay? Moving on down the page, there's just some information here about, I know some of you know this property, the commutative. Notice there is no letter N. It's not commune. It's commutative property. And what this old stuff here, the words, what they're doing is they're telling you in words right here what it means. So you'll see this in your book. So I chopped it in here for you to look at. They're telling you what it is in words. It's the order in which numbers are added or multiplied does not change the sum or product or the answer. Okay. Symbols, they do this. They're going to show it to you in algebraic terms. Okay. And write this down. I'm going to actually fill in a blank here. For any numbers a and b, if you add a plus b, that equals, you write down this, b plus a. That's the multiplicative, I'm sorry, that's the commutative, I said it wrong. That's the commutative property. The order changes, but the answer does not change. Multiplication, if I say a times b, that's the same thing as saying b times a. Okay, so those are symbols showing you those properties. Well, examples, they do the same thing with numbers. Okay, so watch this. This might make sense for you. This is on your paper, right? 6 plus 9 is 15. 6 plus 9 is 15, but I could also say this. Look at it this way, 6 plus 9, that's the same thing as 9 plus 6. Okay, that's the commutative property happening there, and 9 plus 6 is also 15. So what they're trying to tell you here is that you can change the order with addition, get the same answer. That is called the commutative property. And with multiplication, 4 times 7, well, we know that's 28, right? That's on your paper. Well, 7 times 4 is the same thing as, 4 times 7 is the same thing as 7 times 4, which is 28. So there is the commutative property in action for you. And then the last part, I don't believe I have any filling in the blanks for you, but the same idea, the associative property, the way in which numbers are grouped when added or multiplied. Now notice these two are only with addition and multiplication. It does not change the sum or product or the answer. Okay, here we go. If you have any numbers a, b, and c, this looks a lot more confusing than it is. Notice the parentheses around the a and the b. If you add those two numbers and then you add c, you get the same thing as if you add a and b first. If you add b and c first and then add a is what that second part says. It looks a lot more confusing here. Let's go down to the bottom and see if we can make sense of this. Notice if I have 3 plus 6 plus 1, it's the same thing as if I have 3 plus 6 plus 1. You get the same answer either way, right? Let's look and see. The answer on the left, this is on your paper, just please watch. 6 plus 3 is 9. 9 plus 1 is 10. Over here, see what they did first? 6 plus 1 is 7. 7 plus 3 is 10. That's called the associative property. And the same thing is true of multiplication. here. If you multiply those two numbers and then multiply this, get the same thing as if you multiply those two and then multiply those. That's called the associative properties. All right, I'm going to stop the video here, and in the next video, we're going to do some examples together and see if we can identify those properties.